Hello everyone. Myself Mriganka Gogoi. I work as an assistant professor in the Department of Electronics and Communication Engineer, Assam Don Bosco University. And this university is actually under the Society of Don Bosco, which is present in almost 132 countries all over the world. And today my talk will be on semiconductors as a critical industry for post-COVID economic recovery with the subtitle Addressing the Skill Gaps in Semiconductor Industry and Workforce Creation. The plan of talk includes introduction in India's journey in semiconductor, global value chain of semiconductor, impact of COVID-19 on the semiconductor industry, role in economic recovery, current skill gaps, addressing skill gaps pertaining to Northeast India. As I belong to Assam and it is in the northeastern part of India, so I would also like to focus particularly in addressing skill gaps in this region. And finally, I would like to conclude my talk. If I talk about semiconductor and skip the history, that would not sense if or that would not give a proper direction to my presentation. So let me start with the history of semiconductor. And as you know, semiconductor, which is basically the conductivity of the material, lies between conductor and insulator. And also one of the advantage is that the conductivity of semiconductor can be controlled. And because of this advantage, in 1947, by three scientists, John Bardeen, Walter Brittain, and William Shockley in Bell Laboratories, USA, they invented an electronic device called transistor. And because of this transistor, there was complete revolution in the electronic industry. And then came in 1960s by Jack Kilby of Texas Instrument and Robert Noyce of Fairchild Semiconductor. Robert Noyce is also one of the co-founders of Intel, and they independently invented IC, integrated circuits, where today billions of transistors can be embedded. And then in 1969, the first memory chip, again invented by Intel, which could store 64 bits. And it was named as Intel 3101, as you can see in the picture. And then again in 1971, Intel introduced or invented the first microprocessor. And after this invention, today almost in many of the electronic components, microprocessor is an integral part. And without it, there is no use of that particular device or instruments. Well, talking about India's journey in semiconductor, in it started with India's cabinet approval in 1976 for establishing a semiconductor laboratory in Chandigarh or Mohali now. And after that establishment of the laboratory, there was a big gap. And in 2014, Ministry of Electronics and Information Technology, MITE, so they partially funded a project called Shakti to IIT Madras under the leadership of Professor Kamakoti. So in this project, they plan to design some, kind of processor or chip. And in 2018, they successfully developed this processor called Shakti, and with a technology from Semiconductor Laboratory of 180 nanometer. And then, there is after a gap of around a few years, we all are familiar with these three semiconductor units established by Tata Electronics, two in Gujarat and one in my very own place in Assam. And when we talk about these three semiconductor units, the one which is in Assam, it is basically for assembly, testing, and packaging. While in Gujarat, one is fabrication lab, and another one is again assembly, testing, and the packaging unit. Along with the Tata Electronics, there are also other companies which are associated, like Power Semiconductor Manufacturing Corporation (PSMC) from Taiwan, and also one company from Thailand, another one from Japan. So it's a collaboration of very expert companies who will be manufacturing the very own, the manufacturing from India itself of various ICs. Now, when you talk about global value chain of semiconductor, we can categorize like starting with pre-competitive R&D, then comes the design of the circuit, and design needs to be supported by core IP or intellectual property. These are standard blocks which will be used for designing the circuit, and then electronic design automation companies, so they will be providing the tools for designing the circuits. Then there will be wafer fabrication, which is front end manufacturing. So that is the design needs to be fabricated, so it will be done at this stage. Along with that, after the designing or after the fabrication, there will be assembly, testing, and packaging. So this wafer fabrication, assembly, testing, and packaging will be supported by raw material suppliers as well as semiconductor manufacturing equipment suppliers, because there will be requirement of very high-end tools for fabrication. So that will be supported by semiconductor manufacturing equipment suppliers. And finally, there will be distribution. So when we talk about global chain of semiconductor, as it is categorized into five different stages. So pre-competitive R&D, again, there will be involvement from the government side, various autonomous body of government, and there will be funding requirement, and there will be departments like defense which will come into play. And then again, when it comes to IC design, design of cutting edge chips, processor, system on chips, and companies like Intel, Samsung, Apple, they are already doing the IC designs. And after the design comes the wafer fabrication, and which is the front end chip manufacturing. Again, the companies like Intel, Samsung, Taiwan Semiconductor Manufacturing Company, they are doing this kind of wafer fabrication. And the later stage comes are known as the assembly, packaging, and testing. And as I told you that in Assam, in my very own place, one assembly, packaging, and testing unit is set up. So that comes only after the wafer fabrication. Probably after fabrication is done in Gujarat, it will come over here. And a very renowned company called Advanced Semiconductor Engineering in Taiwan. So it is a very popular company, and it's globally renowned. They works in this particular domain. Then there are also other companies in People's Republic of China as well as in USA. And then EDA tools, which is required for IC design or fabrication at different stages. So there are three particular companies, Cadence, Synopsys, and Mentor Graphics, all are from USA. So they covers around 75% of the tools required in this particular industry. Design of IC is again, it is globally distributed in many countries. Design of IC is possible if not fabrication. However, advanced node front-end production is almost exclusively located in Taiwan and South Korea. So advanced node in the sense like, the technology which is used for designing the IC, usually it is named by like, 180 nanometer, 90 nanometer, or 45 nanometer. When we talk about advanced node, it may be 7 nanometer, 14 nanometer, or maybe 3 nanometer. So this type of technology which is required for fabrication are done basically in Taiwan or in South Korea. And front-end production for mature nodes is more geographically diversified in Japan, China, Europe, and the UK and North America. So particularly when we talk about, say, 45 nanometer, 14 nanometer, so those are matured nodes, or 19 nanometer. So those technology which are required for fabrication are distributed among these companies. I mean, among these countries. Uh, in fact, Intel, which has also established fabrication lab in USA, they also go for advanced node as well. And then backend assembly and test is mostly consolidated in Taiwan, Malaysia, Philippines, and China. As I already told you that there is a giant company called Advanced Semiconductor Engineering, ASE, in Taiwan, which is particularly dealing with assembly and testing of ICs. Well, when coming to impact of COVID-19 on the semiconductor industry, semiconductors are a backbone of modern industries, as we know, and the advancement in semiconductor technology determines how far human beings can go in artificial intelligence, autonomous mobility, and next generation telecommunication. The massive disruptions worldwide during the COVID-19, as you know, during the March 2020, the outbreak of this COVID-19 pandemic, it has actually led to severe chip shortages, and that became the key concern of policymakers and business leaders in relation to the increased demand resilience of the existing semiconductor global value chains. Well, talking about the various industries, automotive industry is the most impacted despite being among the smallest revenue generators for most established chip manufacturers. So there were, all of us know that there were shortage of chips during the COVID time, and this automotive industry was very badly hit. And in fact, it also affected many economies of many different countries. Other industries ranging from consumer electronics like smartphones, smart TVs, etc., to power, solar cells, and wind turbines, to computing, HPC, and IoT, high performance computing, and IoT are equally affected. Today, it is the era of Internet of Things. So everywhere, there will be a very smart device required to get connected to the network. And these smart devices again needs processor, which is a primary component of that particular instrument, you can say. And as I told you, processor, which is made of semiconductor. And that's why even the state of the art technology is very much dependent on this industry. Again, well, talking about the revenue segregation among different companies, the mainly it is emphasized on TSMC, Taiwan Semiconductor Manufacturing Company of Taiwan. And then again, the revenue estimate in Q1 2021 was around $12.9 billion. Then comes Samsung from South Korea, around $4 billion. UMC again from Taiwan, $1.6 billion. Global Foundries from USA, $1.5 billion. Similarly, SMIC from China, around $1.1 billion. Tower from Israel, TSMC from Taiwan again, VIS from Taiwan, Huahong from China, DB High Tech again from South Korea. So as I told you, by now you are already familiar that TSMC is the company that provides the maximum percentage of chips or electronic chips all over the world. And this company has very giant clients like Qualcomm, Broadcom, Nvidia, AMD, Texas Instrument, ST Microelectronics, NXP, Renesas. And of course, those companies have other clients too, like Apple, Samsung, HP, Alphabet, Toyota, Ford, Continental, etc. During the pandemic, particularly the shortage of chips happened because of this average waiting time. As you can see, starting from March 2017, in the mid of 2018, that is July, the waiting period increased. However, after that, again the waiting period gradually decreased. But soon after the COVID pandemic, the average waiting period that jumped by 6.5 days, and the longest since data collection started in January, and then by another 6 days in February. So it increased up till 15 weeks. That's the reason why there was shortage of ICs. Well, as the time is progressing, the requirement of semiconductor units are also increasing, or the demand for the semiconductor units are gradually increasing. And if you see from 2015 to 2021, the amount of semiconductor units shipped worldwide are quite are gradually increasing. And similarly, you can also see global semiconductor revenue and year over year percent change are also gradually changing, except in 2021 because of the corona outbreak or COVID-19 outbreak. And in terms of revenues in different sectors, if we talk, computing takes the highest amount of revenue, or it consumes highest number of semiconductor chips by dollars 160.2 billions. And then wireless domain and consumer, automotive, industrial, communications, and infrastructures. Talking about role in economic recovery after COVID-19, the disruption in chip shortage made international governments and companies aware of the fragility of the chip supply chain and the critical dependence on certain countries. So many governments realized about the necessity of these semiconductor industry, or how the semiconductor industry can be a backbone for a country in terms of economic. In response, the world's major economies are striving to regionalize production by encouraging the establishment of offshore foundries. And between 2021 and 2023, construction commenced on 24 new foundries, and with a total investment of around US dollar 500 billion. And India too participated in this race by establishing the Fab unit in Dholera, Gujarat, by Tata Electronics in collaboration with PSMC, as I already mentioned. And apart from the two assembly testing packaging units, in one in Gujarat and one in Assam. This infrastructure obviously will need huge manpower to operate, and current skilled professionals will not be sufficient to fulfill this demand. So hence it is essential to take measures for creation of the required workforce. So the post recovery, if the economy has to recover, and as you know, the governments of different countries are already emphasizing or already started investing in this particular industry, so there will be definitely requirement of the workforce. So but if we talk about this industry, infrastructure and workforce, these two are vital parts of the ecosystem. And already we have infrastructure, or the government have already started investing on the infrastructure. So next part is the creation of skilled professionals or the workforce, and how we should address in creating this workforce that is of concern. Talking about current skill gaps, even before the current wave of investment, the semiconductor industry saw a significant increase in demand for qualified candidates. There were demand, in fact, before the pandemic as well. And from 2018 to 2020, job postings for semiconductor technical roles in the European Union and the US rose at a CAGR of around 75%. And if the sector does not become more attractive, the talent gap for engineers will exceed 1 lakh in both the US and Europe, and over 2 lakhs in Asia Pacific, excluding China. And in Asia Pacific, there are major disparities. India could potentially export engineering talent, while Japan and South Korea face severe shortages. The number of new graduates hasn't kept pace with the job openings, leading to increasing demand for talent in the industry. And if you see the requirement in this industry in different sectors, so particularly in systems architectures, then AI and machine learning, knowledge of applications, even knowledge of new materials, analog design. So after 2022, or in 2022, the demand in these particular sectors are growing. compared to the other skills in 2020. Well, talking about the education reforms, the first point that I would like to emphasize is the curriculum modernization. The various education bodies like AICTE, All India Council for Technical Education, or UGC, or other bodies, if they are going to uh, introduce courses in semiconductor domain, then they have to come with modern curriculum so that it fits with the industry needs. Similarly, there should be collaboration with the industries. And from my point of view, what I would feel that the industry, if they can produce the, or they can give the problem statement what they are facing, and then that statements shared with the universities, and finally a university or academic institutions collaborating to work on that problem statement can be really beneficial or efficient. And then specialized training programs, when of course when you are going to create a workforce in this particular domain, there are many tools needs to be learned, there are many equipments needs to be learned, there are new materials that needs to be well, that will come under, when we talk about materials, that will come under research and development, but particularly which are the existing tools. There are different companies, as I mentioned before, like Synopsys, Cadence, Mental Graphics, who are providing EDA tools. So the workforce should be trained with these tools, which are required to be used later on in the industry. And increasing fund and resources, of course, for the academic institutions to carry out research or to carry out project in this particular domain, if there are funding provided by the government, so it needs to be increased as we progress, or as we go, as we want to make impact in this particular industry. Then facilitate exchange programs, as I have already talked about Taiwan, USA, China, or other countries which are working in this particular domain and who has many expertise. So it will be always essential for the exchange of these resources or the workforce that we are going to create, so that they learn the technology, they learn the tools from the experts. Well, in the context of India, if I have to say, uh, then AICT has already launched courses in semiconductor to make India self-reliant in chip manufacturing. AICTE has introduced courses in semiconductors such as VLSI designing, IC integrated chip designing, semiconductor management, then silicon chemical extraction, etc. And when talking about the addressing skill gaps, well, Tata Electronics has signed memorandum of understanding, or MOU, with Synopsys, a leading provider of silicon to systems design solutions, to collaborate on process technology, bring up and foundry design platform to accelerate the successful ramp of customer products in India's first fab being built by Tata Electronics in Dholera, Gujarat. So at this point of time, I would like to particularly focus on this company called Synopsys, which is really actively working with Tata Electronics, and in fact, Maite, for giving training or for creation of this workforce as well as technology support to the company. The various schemes like India Semiconductor Workforce Development, which is leading by IISC, Indian Institute of Science, and it is supported by Synopsys, again, the technology that to be used. And then again, Center for Semiconductor Technologies in IIT Bombay. So they also introduced some courses, training courses, like short-term course on semiconductor manufacturing with hands-on training, and this is again supported by Synopsys. Well, coming to the EDA tools, Government of India, Ministry of Electronics and Information Technology, they started a scheme called Chip to Start program. And under this program, they have actually implemented to use various tools by the institutes. So initially they started with around 100 institutions, and probably by now around 50 institutes are already associated to use these tools. And as the time is passing, so gradually many institutes are getting enrolled under this scheme to use these different tools. So I mean different tools. So if these tools are made available to different institutes, and it would be very easy for creation of this workforce, or the creation of the workforce required for this particular industry. I remember when I in fact I am still doing research in semiconductor domain, particularly in circuit design. So when I started in doing research in circuit design, there was very difficult to find the tools, and we really struggle to get this kind of tools. But with uh, Government of India taking initiative, particularly Ministry of Electronics and Information Technology, taking initiative to give these tools to various institutes, I think it is a big breakthrough for the Indian semiconductor industry, and it will help in creating this workforce within a very short span of time. So particularly when we talk about the tools, these tools are ANSYS, Synopsys, Cadence, Keysight, Siemens. So these are the companies which are providing semiconductor related tools, which are which the workforce should be acquainted with. Again, AICT has collaborated recently. I came to know about this. AICT is collaborating with Taiwan's Xian Foundation of Science and Technology to provide semiconductor related training to students and faculties of institutions under its affiliation. I have also visited many labs in Taiwan, and I have seen the facilities they have. So I think the workforce that we are focusing on, if we give or if we give the platform for them to visit those labs and undergo training there, so they will be very well equipped or expert professionals in this particular domain. So a special attention needs to be addressed in particular, India Taiwan collaboration, particularly for the growth of the semiconductor industry. And there are of course news of India and Taiwan relationship is growing stronger and stronger. Well, in the context of Northeast India, if I have to tell, we have been, as I told you, I am an assistant professor in the Department of Electronics and Communication Engineering, Assam Don Bosco University. We focus on addressing the skills required for this semiconductor industry, particularly in terms of collaboration with different universities. Well, we have a close connections with Taiwan. All over India, there are actually Taiwan education centers, and to the best of my knowledge, 35 Taiwan education centers are currently present in different universities or different institutions in India. These Taiwan Education Center actually impart training on Mandarin. Apart from that, they also give scholarships to the students to go to Taiwan and maybe learn Mandarin or do internship or undergo semiconductor training. I am also a receiver of one of such scholarships, which is called as Guwahati Enrichment Scholarship. I have also undergone Mandarin language training from a Mandarin teacher who is in our university under the banner of the Taiwan Education Center, Ms. Kwemi Lee. So I have been learning Mandarin. Still, I'm continuing that, and I got a scholarship to go to Taiwan. Which the scholarship, as I told you, its name is YU Enrichment Scholarship. I went for 3 months, and along with learning Mandarin, I came to know about the culture, about the work system or the ecosystem there. And particularly, I went to semiconductor related laboratories. There is a lab called CREST Lab, Center for Reliability, Engineering, Science, and Technology. So they deal with many semiconductor related projects, even from TSMC, and also they deal with reliability on electronic components. So it was a very good experience, and from my experience, what I have learned there, that the time management is very important for important that to be imparted to the workforce that we are going to create. And visiting those laboratories will give a practical learning as well as experiential learning. So these two are vital for the work system, and to I mean to become professionals later on. And so currently we have around collaboration with or MOU with 10 Taiwanese universities. And we conduct student exchange program, and slowly we are also going for faculty exchange program, and we are also planning for some courses in particularly in semiconductor domain, that could be partly conducted over here and partly in Taiwan. From the Northeast as a university, I confidently can say that we are in a very good position to create the workforce for the semiconductor industry. And also, apart from that, we also have a MOU with Foxconn. Foxconn is again a biggest supplier of electronic components to Apple, and it has already established many offices in India. So it is again a very very well positioned for us to have a industry and academic collaboration. So we are as a university in a very good position in terms of industry and university collaboration, particularly related to semiconductor industry. And recently, we are also going to organize one international conference on emerging and environment sustaining renewable energy. And we are going to collaborate with five Taiwanese university: Chanshui University, Taiwan; National Quemoy University, Taiwan; National Chongchen University, Taiwan; uh, Kunshan University, again Taiwan; Fujian Catholic University, Taiwan. And again, in terms of training, we have giving training in different domains of semiconductor after the COVID, and particularly in terms of digital as well as analog domain. We give training for IC design. We give training for tools like Xilinx or FPGA, field programmable gate array, where you can just write some hardware descriptive languages and design a circuit. In fact, also PCB design. So we have been giving training to various universities, students of various universities. So in a way, we are actually contributing on creating this workforce very rigorously for the semiconductor industry. And again, from the ADBU perspective, talking about skill gaps, I am also involved in writing various articles, encouraging the students of this particular region, or creating awareness among the people of this region to move towards the semiconductor industry, or to go into the semiconductor industry, learn the various tools. And also we have been encouraging to use open source tool as well. uh, as you can see, some of the training we have already conducted, like in eSIM Skywater 130 nanometer. I have also fortunate to meet His Excellency of Taiwan Embassy in New Delhi to discuss about various matters related to creation of the workforce. And well, again, another very important point that I would like to emphasize is the startups. So startups can play a very important role, particularly in terms of IC design, if not wafer fabrication or the circuit fabrication, because the requirement of fund for the circuit fabrication is quite huge. But for designing of ICs, going into that would be very easy, or it would not require much fund. So finally, I would like to conclude my talk with this statement that it is imperative that all stakeholders, particularly parents, students, government bodies, academic institutions, and research institutions, collaborate to motivate and create awareness with accurate information. This concerted effort is essential to developing a skilled workforce and bridging the existing skill gaps in semiconductor design and manufacturing. And also at this point of time, I would like to thank Professor Rai for inviting me to give a talk on this particular burning topic, and also Dr. Neha Sharma for facilitating with this particular talk. And with this, I would like to conclude my talk. Thank you so much.